Okay, so welcome to week 2, part 2. We're going to pick up where we left off yesterday. We have base data types, low-level data types in Python: int, float, stir, bool, the special value none. And we're going to look now at conversions back and forth among these low-level data types. A particular kind of conversion that's important to us is converting from strings to numbers and converting from numbers and booleans back to strings. Very often when we read data from a user or from a file, it comes in the form of character strings, and we have to convert that data in order to do computations into ints or floats, or in some cases bools. We then do our computations, and of course we have to convert back into stirs for the user to be able to read results. Just about anything can be converted into a stir through the use of the stir conversion function. If I say stir of the special value none, all the stir function does is to create a stir containing none in quotes. If I convert a float into a stir, then by default, if that value will fit, it's converted into a so-called fixed point notation without an exponent, and quotes are put around it. If the number is too large or too small in magnitude, then the exponent will be included. So for example, if I had a value, all right, so here I've got a value 12.354 times 10 to the 8th power, and that can fit fine into a fixed point notation with no exponent. But if I had 1.23 e to the let's say 100th power, then that's much too large to be reasonably displayed in fixed point format, so the exponent is included in that case. I've got my actually, I think I did not create this thing yesterday. I just went directly to the keys iterable. So let me create. Okay, let's remember N to E is our dictionary of names to email addresses, and N to E dot keys is an iterable over those keys. If I convert that iterable into a string, it's not really very informative. I simply get the same value that's displayed as the representation of the keys, but with quotes thrown around it. All right, so it is possible to convert anything at all into a stir, but sometimes that conversion is, may not be that useful for a user to read. All right, now converting to int in the case of floating point values will chop off the fraction part, and this is true both for positive numbers and negative numbers. That is, if I say int of 4.567, I'm going to get the integer part of this. It's not rounded. The fraction is truncated, and so what I get from int of 4.567 is just 4. And likewise, this is true for negative values. The fraction is truncated towards 0. Notice that this is very different from the floor division. If I say minus 4.567 floor divided by 1, let's say, then that's going to be truncated toward negative infinity to give me a floating point minus 5.0, whereas the direct conversion to int just chops the fraction off. You can convert a string to an int, assuming that the string does represent an integer value. If I try to convert some nonsense into an int, I get a complaint. I can also convert Booleans to integers, and it turns out that true converts to the value 1, whereas false converts to the value 0. Alrighty. Converting to float always works for integers, unless the integers are too large. If I convert the integer 5 to a float, that works fine. And if I convert the string 5.432 to a float, that works fine. But just like with the int conversion, if the string is nonsense, then I get an error, I get yelled at. And likewise, if I try to convert, recall that I can compute 100 to the 100th power just fine. But if I try to convert, well, actually, was that? So that's 10 to the 1000th power. That might actually fit. Let me do something that definitely won't. Let's do 1000 to the 1000th power. All right, well, not multiplication. We want exponentiation. There we go. Okay, that definitely won't fit. And in a float, and so if I try to convert that value to a float, I'm going to get an overflow error. Okay. Now, as far as Boolean values are concerned, Boolean conversions, it turns out that any numerical form of 0 converts to false. Also, an empty string converts to false. So if I say bool of 0, that's false. That's an integer converted to bool. If I say bool of 0.0, that's a float 0 converted to bool. And if I say bool of an empty string, all right, that's 2 single quotes side by side, that is false. But pretty much anything else is converted to true. So bool of 0.01, many zeros, converts to true. Bool of 1234 converts to true. Bool of a string containing a space. All right, it doesn't look like that string ought to be considered important, but since that string does contain a character, it converts to true. And of course, any other string containing any characters also converts to true. Okay, so that takes care of the conversions back and forth among the low-level data types in Python. Next up, we're going to take a look at a monstrous beast called Beautiful Soup, which I don't know. I mean, it's the name of this thing is a multi-dimensional joke in a way. Beautiful Soup is the simplest widely available tool for doing what's called scraping a website. That is, going out to a website and pulling down all of the data from the website and converting that into a form that you can work with within a Python program. And the steps involved are you make a connection to some web page, you download the source code of that web page, you then use the Beautiful Soup construction function to convert that into a structured Beautiful Soup document. Now, Beautiful Soup understands HTML formatted documents. It understands the hierarchy of tags that exist within HTML and gives you a way of selecting and interacting with the nested parts, the nested components within the HTML. Now, before we start trying to pick apart that HTML and pull data out of it, it's very important to store that Beautiful Soup object into a file that you can then just look at with a reasonably powerful text editor to get an understanding of the structure of that HTML. You cannot suck down an HTML document from a web page and start parsing it with Beautiful Soup without knowing what the data actually looks like. So looking at the data that you get, looking at the source code that you've downloaded in Beautiful Soup form is a critical part of this whole process. Once we've identified the tags for the various parts of the data that we care about, we can use Beautiful Soup to conveniently extract the information that we want. All right, so I have a program that should be available on Canvas. In fact, I am going to pause for a moment and make sure that this thing is available for you on Canvas. It's called BSoup 1. All right, so let me pause and check that out. Okay, it is indeed posted on Canvas, so let's go ahead and take a look at this code. Here we have the BSoup 1, Beautiful Soup version 1 Python program. And I'm going to open that in my idle editor. I can go up here and say File, Open, and here's my bsoup1.py file. I have already opened that, so I'm not going to open it again. If I wanted to open it, I'd click Open. I'm just going to click Cancel. And here is that file. All right. Now, in order to access an online web page, we need to import from a module named urllib.request a function named urlopen. All right, so from urllib.request, we're going to import urlopen. We're also going to, from the BS4 module, which is one of the modules that was installed as part of Anaconda, assuming that you installed Anaconda correctly, well, perhaps not the most recent version of Anaconda, but a recent version of Anaconda. We're going to import the Beautiful Soup. Technically, this thing is called a class, and we can use Beautiful Soup to create Beautiful Soup objects. All right, now what I'm interested in here, one of my other hats is to teach in the Tepper School's MS in Computational Finance program, and we're all concerned in that program about things like stock prices and interest rates and bond prices and so on. So let's find out about the yield curve. The yield curve has a powerful impact on finance. Let's see what we can find out about the U.S. Treasury yield curve. And daily Treasury yield curve rates. Okay, so this affects things like not only investments, but also affects things affects things like mortgage rates and interest rates for auto loans and the like. And here we go. Okay, cool. So this web page has a nice table of recent interest rates, and we can see this literally historic, shocking emergency cut that took place recently to bring the short-term interest rates down almost to zero. And even out at the long term, the interest rates are below 1.5% as of yesterday. That's quite extraordinary. Now, I would rather have a larger amount of data to work with, so I'm going to, just for illustration purposes, look at all of last year, 2019. And here we go. So now we have a year's worth of data, starting from January 2nd of 2019. Well, that didn't work very well. Yeah, January 2nd of 2019. And then for every business day, for every day that the markets were open through December 31st of 2019. So approximately 250 days thereabouts. Weekends are not going to be in this table. Holidays are not going to be in this table. You can see that the table starts on January 2nd, not on January 1st. And for each day, we have interest rates ranging from 1 month up to 30 years. Okay, now in order to pull this into a Python program, we can use our URL open function with the URL that appears for the web page. And actually, I guess I need to drag this down a little bit so that you can see it. All right, so here we go. Here's the URL, and so we copied and pasted that into the program. I'm going to call URL open to open access to that website, and I get back a handle, if you will, that I can use to communicate with that web page. Now, from that web page that I'm using the variable HTML to refer to, I'm going to read the contents of the web page, and from those contents, I'm going to construct a Beautiful Soup object. Now, Beautiful Soup has various formats that you can use to interpret the contents being read in. I'm not going to pretend to be an expert on all of these things, but LXML is a very common format to use, and in this case, that is able to process the HTML contained in this Treasury yield curve table, web page containing the table. And what I get back from the Beautiful Soup construction function is this object that I'm calling BSYC. BSYC for Beautiful Soup yield curve. Okay, so Beautiful Soup yield curve is my object containing a hierarchical structuring of the data in that web page. And the first thing I want to do now that I've obtained that is to store that into a file, into a text file that I can edit with a powerful text editor to just poke around and see what's going on. So I'm going to open this file called bsyctemp.txt for writing text. So this will be an output file, and I'm using UTF-8 as my encoding for that file, which, as we've said, incorporates the 7-bit ASCII character set within it. And I'm now going to convert the Beautiful Soup yield curve object into a string and write that string out into this fout file and close the file. Once I've done those steps, I can then edit this file with a text editor to see what's going on in there. And let us do that part. Let me pull my program up here. Now, after I have done this close, I don't want to do any of the remainder of the program at this point. So I'm going to use my triple quotes as a trick here to comment out the entire remainder of the program. That's a very common use for the triple quotes, is to just comment out a big block of code. I mean, technically you're wrapping that block of code into a string, but since the string isn't used for anything, it's as good as a comment. All right, so now let us save the file and run it. Run module is how we run a program in an editor, in the idle editor. And that restarts the shell, runs the program. I got a prompt. I didn't get any error messages, so presumably that did actually create that bsyctemp.txt file. On my system, I have a Linux-like environment called Cygwin installed. And my favorite reason for that environment is that it allows me to use the VI editor, which is a very powerful editor. I'm in my DFPA4 2020 directory, and indeed I see that I do have a bsyc temp.txt file that was created here. In fact, if I do an ls-l, I can see that it was just created. Let me edit this thing with my VI editor. Now, why do I say that VI is a powerful editor? Well, it's an editor that's able to edit files that are almost arbitrarily large. I can edit files that are many megabytes in size, and I can search for patterns, I can do substitutions, I can use regular expressions, which we'll talk about a little bit later. What I want to check is to see if I can locate this table. All right, let me pull the table back up here. I want to see if I can locate where this table is in this web page. I mean, there's going to be a heading area. There's this sidebar here. There's various icons being displayed. But what I want in particular is this table of interest rates. So let me see, just to pick one, let me see if I can locate August 1st. Let me see if I can locate the data for this particular line, August 1st of 2019. And see if I can locate that data. Okay, so I will do that in my editor. All right, let me search for 08/01/19. Notice that in the VI editor, I mean, this is irrelevant if you're using some other editor, but you should have access to some powerful text editor. In the VI editor, I use a slash to perform a search. And consequently, since the slash is part of the date that I'm searching for, using the slash is very awkward in the pattern that I'm searching for. Consequently, I am using a regular expression character here that we will discuss, namely the dot. Dot stands for any character. So technically what I'm looking for here is I'm searching for 08 followed by some character, followed by 01 followed by some character, followed by 19. And in fact, I found a first copy of that. Let me continue searching for the same thing to see if I find another occurrence. Okay, cool. I get told search hit the bottom, continuing at the top, and I'm back to the very same string. So that implies that wherever I am in this text file, I must be within that table that I'm interested in. Okay, so I must be within this part of the table that I'm interested in. And in fact, if I look a little bit later on, I see 2.11, 2.14, 2.07, and those are the 1 month, 2 month, and 3 month interest rates for August 1st. Cool. All right, now, if you don't know anything about HTML, that's fine. You can poke around in Google and find out pretty much everything you need to know pretty quickly. For example, here I have, well, let's see now. Okay, so I do know, the little bit that I do know, well, by now I know a little bit more. But when I was first learning HTML, the little bit that I did know informed me that tags for components in an HTML document started with a less than symbol and some string. And from the data that I'm interested in, 08, 01, 19, if I go backward looking for a tag, here's that tag, and Googling for left send sign TD tells me, oh, this is a piece of table data in an HTML table. So now that I've learned a little bit more, I'm going to search backward for the tag table. All right, so I'm going to search backward for a less than symbol and table. The way I search backward in VI, of course this will be irrelevant if you're not using VI, but the way I search backward is to press a question mark and then search for less than sign table. And there we are. Okay, so the table that incorporates this bit of information for August 1st of 2019 starts with class equals t-chart and blah, 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 blah. Now that makes me very curious. Is there some other class equals t-chart table in this HTML document? So let me search for table class, whoops, sorry, no quote, class equals t-chart. All right, I found one. If I'm unlucky, maybe there's another one. All right, so I found one. Let me look for another one. All right, I looked for another one, and I got the same message, search hit bottom, continuing at top. So this must be the table containing these Treasury interest rates. And, you know, obviously that pretty well makes sense because it is, you know, T-chart for Treasury chart after all. If I look a little further along in here, I discover, date, 1 mo for 1 month, 2 mo for 2 months, 3 mo for 3 months. And if I do a little more Googling, I discover, oh, okay, cool. TH is a tag representing a header for a table. And if I flip back to my table, I see that, here we go. Okay, so we've got date, 1 mo, 2 mo, 3 mo, and so forth. That must be the line representing the header information. And just prior to that header information, I see TR. A little more Googling tells me, oh, this is a table row. So what I have here is a table, and the table contains rows, and the rows are either header information. Turns out this table only has one line of header information, or when I get past all the THs here, all right, here's the end of that table row that has the header stuff in it. And here's the next table row, which has data in it. Table data. All right, and this is for the first trading day of the year, January 2nd, 2019. Good, good, good. All right, so in other words, a table contains rows, and rows may contain either header information or data information. So it's a hierarchical kind of structure. The next thing I want to do, now that I've discovered that that I am able to identify within this massive file where that table data is I want to see if I can start identifying this stuff within my Python code. So the first thing I'm going to do within my Python code is I'll move this triple quotes down and just print sorry, I changed my window size other than highlighting there. I guess it doesn't matter that much. I'm just going to print the table data out of this Beautiful Soup yield curve object. Okay, so let's just print the table data as output from Python. We'll save this. I can either say File, Save, or I can use the shortcut key Control S. I'm going to press Control S, and now I'm going to run this program. I can say Run Module, or I can use the shortcut key F5. So I'm going to press F5. And okay. I got a lot of output. I don't know if you can see this in the video, but it says squeezed text, 2,283 lines. Let me double click this guy to unsqueeze it. The squeeze output is very long and idle could be slow. I'm going to risk it. I'm going to click OK. There it is. Okay, so I've got this huge amount of output now. Here's a table. And idle is indeed being very slow here. Come on now. Good heavens. Boy, it went way back. All right, so here we go. So here is a table. This is not the table I want, because the table I want says table equals t-chart. This looks like the very first table, which is kind of just icons and stuff at the very top of the page. Goes on and on and on. Here's another, here's the table of interest rate stuff. That's going to be a really long table. And then eventually I may find some more tables in here. I'm just going to abandon this process because I'm not interested in seeing all of the tables after all. So let me comment that print line out. And it turns out that another facility, another function that you can use with BSYC, in addition to saying BSYC.table, which displays all the tables, is I can do a find all of table. I can do a find all of some arbitrary HTML tag to get a list of all of the objects that have that tag. So instead of just getting the raw text for all the tables, this is going to break the tables out into a list. And let me move my triple quotes down. Let's find out what the length of that list is. That will tell us how many tables this page has within it. All right, so I'll save this and run it with F5. Okay, there are 8 table tags. That means that this HTML document contains 8 tables within it, and I know that I'm really only interested in one table, the one that has that T-chart label on it. Now, each table is potentially extremely long, and I would like to look at just the beginning of each one of these tables. So I'm going to use a slice trick here. Since this table list contains the text for each one of those 8 tables, in other words, each item in there is an entire table, I'm going to use a for loop so that T gets set to each table, one table at a time. I'm going to convert that T into a string so that it's in human readable form. And rather than displaying the entirety of each table, I'm just going to display the first 50 characters. Okay? Square bracket colon 50, remember, is a slice notation for a list, and it says to me, let's display characters from character 0 up to character 49, not including character 50. But, of course, 0 through 49 is 50 characters. So that's going to give me the first 50 characters of each table. Let's see how that works. Let me save this and run it. Control S and F5. And cool. Okay, so here is apparently the first 50 the first 50 characters from the first table, and then the first 50 characters from the second table, and the third, fourth, fifth, sixth, seventh, eighth. So I've got the first 50 characters from each of the 8 tables. And what I discover here is that it's the second one in this list that I want. Now, at this point, I could just hard code, okay, get me a list of all the tables, and then give me the sub1 element, the sub1 item out of that list. That will be the T-chart table. But it's risky to hard code an assumption that in the future, this table of interest rates will always be table number 2 in this HTML page, because somebody's going to come along and reformat and beautify this web page at some point. We will hope that the interest rates remain in a table labeled T-chart, but we're not going to take the risk that that's always going to be table number 2. So what we'll do is let's see, what we'll do is we'll say, okay, now instead of finding everything named a table, everything that has table as its tag, let's constrain that to look with findAll for things that have table as the tag, but within that also have the class set to T-chart. Now, this part here, this is a dictionary, and it's part of Beautiful Soup. Okay, BSYC is my Beautiful Soup yield curve object, and in the findAll function, not only can I specify a particular tag that I want to look for, but I can specify a dictionary of label equals value. And I could have multiple items within this dictionary. But in my case, all I care about is that I find the one that says class equals T-chart. Now, findAll always returns a list, but in this case, we're hoping that that list only has one item in it, namely our T-chart table. I am going to comment out some of these previous things because I don't care about those anymore. So that now when we run our program, we are just going to see the number of elements in this list of T-chart tables. And I really hope that there's only one. Well, I know at this point, because I've used my VI editor to analyze the file directly, I know at this point that there is going to be only one. So let me run this, Control S and F5, and yay, there's only one T-chart table. Okay, so I want to use just that one table. It is a list. It's a list of just one item. So list sub 0 is the item. All right, so T-chart table is TC table list sub 0. And as I've mentioned, Beautiful Soup structures the HTML information as a hierarchy. So the table is going to have some number of children. Any tagged thing has children, child tags within it in this hierarchical structure. So I'm going to ask to see the children of the table, which should be the rows. Remember, I mentioned this before, that the children, the direct things that make up a table are rows. So I'm going, hopefully, to get the rows here, and I'm going to use my same string slicing trick here to just see the first 50 characters from each row of the table. And that's all I want to do, so let me throw my triple quote back in here. Okay, I no longer care to see that there's one T-chart table. I'm going to comment that out. But I do need to retain, find all of the T-chart tables, then get the one and only T-chart table from the list, and then I'm going to display the immediate children within the tables, which should be the rows. And okay, it goes on and on and on. All right. Because there are, as I mentioned, something like 250 rows in the... oh, I went back too far. Try not to go back quite so far. There are going to be about 250 rows in this table because there are about that many trading days in the year when you throw out holidays and weekends. Here is the first row, which is the row of header information containing date and 1mo and 2mo and 3mo and so on. But I'm only displaying the first 50 characters. Now, the individual rows within the table for the individual days have this long preliminary descriptive stuff. So I'm not actually seeing any data here. Some of these rows, every other one in fact, is an odd row, and some of these rows are even rows. Can we tell any difference between odd rows and even rows? When we look at our web page, let's see. All right, well, now, whether you can see any difference depends on the contrast of your screen. And my screen is set up to not have very good contrast. If I were working with a different screen that had better contrast, what I would be able to see is that the odd-numbered rows are light-colored and the even-numbered rows are slightly darker colored, just to aid readability of this thing. But I can't tell that on my screen the way I currently have it configured. All right. So we've got the rows. The rows are the children of the table. The first row contains header information. The remaining rows contain data information, but the actual data is beyond the first 50 characters. So let's break this out some more. All right, now based on Googling, we know that the HTML document is hierarchically structured, and within each row is going to be some sequence of data elements. So rather than seeing just the rows, I'm going to go down one more level with this next for loop, and I'm going to say for the children of the table, all right, C is a child of the table, so C is representing a row, which I realize is a little, okay, so C for child, and the children of the table are rows. And then for each child of the row. Now the children of the row for the first row are going to be header information, and for all the subsequent rows are going to be data information. So let's take a look at all of the header and data information from every row in the file. All right, a table contains rows. Rows contain either header or data, and we're going to look at that level of the output. This is going to be very long because each row has 13 columns in it, and we've got, as I said, roughly 250 rows, so 2,800 lines of output here or whatever. And rather than going all the way back to the top, which will take a while, let's just notice here we have the table data for the very last row in the table. And let's see if that actually makes sense. The date for that row is 12/31/19, and we have interest rates 1.48, 1.51, 1.55, etc. Let's look at our table again. $1.48, 1.51, 1.55. Okay, so good, cool. We have indeed now found the values that we want. We have found the dates for each trading day, and we have found the interest rate values. Now, they're not in a very convenient form because they've got all this HTML wrapping stuff around them. From these cells in the table, I really just want the strings representing the dates, 12/31/19 and so on, and I want the numbers representing the interest rates. So I'm going to have to take one more step to just collect the data out of each of these cells and throw away all that wrapper stuff. Okay, so we have found the table data, and now we want to just get the contents of each of those cells rather than the entire HTML description of each of the cells. So we're going to use our same nested loop that we had. We're starting with our T-chart table. The children of the table are the rows. The children of the rows are the fields, the columns. And I want to get just the contents of each one of those cells. I'm going to comment this for loop out so that all I have left is, okay, way up at the top of the program, I have created my Beautiful Soup object by reading and processing the HTML from that web page. Then I have gotten a list of all of the tables where class equals T-chart, and fortunately there's only one of those. So I have grabbed the first item from that list, which is my T-chart table, and now from within that table I'm asking for the children, which are the rows, and I'm asking for the rows children, which are the cells, and now I'm going to ask for the contents of each of those cells. Let's run this, and cool. Okay, this is also going to be a very lengthy output. So these are the cells. Now I can actually work with these. Each one of these things that's being displayed here is a list that is just one item long, and each value within these lists is a string. So when I continue doing further processing on this information, I'm going to want to leave the date represented as a string, but I'm going to need to convert these strings for the interest rates into float values that I can actually do computations with or do graphics with and so on. Okay, so that is a brief run through of using Beautiful Soup to download a web page, identify the various tables within the web page, then within the table to identify the rows, which are the children of the table, and the cells, which are the children of the rows. And then finally to get the contents of each one of those cells, which gets us to the point where we can start actually doing some stuff with that information within our Python program. Okay, now, Beautiful Soup is one way of scraping web pages. It is the simplest way, and it's also the least sophisticated way. It only works with traditional old-fashioned HTML kinds of documents. It doesn't work with active JavaScript kinds of documents. In your project, you're not going, pardon me, in your project, you're going to need to do web scraping, and it's very likely that some of the web pages that you scrape will be active rather than passive HTML. So you may need to use alternative scraping tools such as Selenium or Scrapy. And very likely there are other scraping tools that are available that I'm not even familiar with, because of course the Python ecosystem, as it's called, keeps growing with new tools available all the time. So I'll make a note of these couple of alternatives. We've got Beautiful Soup for straightforward HTML documents. We've got either Selenium or Scrapy for dealing with active documents whose contents are not fixed in just plain HTML. All right, so that gets us to the conclusion of this material.